Hi Math 30-2 students. So this is the probability unit. So this is lesson 3.1 and 3.2 combined. So we'll skip example number 1. So what you want to do is make sure you take notes and then ask questions if you're not understanding this. So example number 2, for something to be fair, each person, individual playing a game should have equal chances of winning. Okay, so what we're going to do is in example number 2, we're going to figure out if the games are fair or not, and we're going to figure out who has the advantage. So if it's not fair, we want to figure out who is most likely going to win the game, and then we'll explain using the math. So let's look at Matt and Pat. They each toss a coin. So they each have a coin, they're tossing the coin. So these are the different outcomes that can happen. So Matt could toss a tail and Pat could toss a tail. So in a coin, you can either have a head or tail option. Matt could toss a head and Pat could toss a head as well. And then you can have Matt tossing a head and Pat tossing a tail, and then Matt tossing a tail and Pat tossing a head. So those are all the 4 options. Now, if the coin lands as both heads or tails, both tails, then Matt wins. So I'm going to circle where Matt wins. So Matt's going to win where they're both tails and they're both heads. And now I'm going to circle where Pat wins. Pat wins when the coin lands as a head and a tail. So these are the 2 options. So we can tell just by looking at this that this is a fair game, therefore a fair game. The reason being that Matt has a 2 out of 4 probability of winning, and so does Pat. So they both have a 2 out of 4 chance of winning, which we would simplify them both to be 1/2. So they both have equal chances of winning. B, Trina, Lena, and Gina each toss a coin. If all 3 coins land as heads, Trina wins. So let's say that Trina is the first person tossing. She could get a tail, Lena could get a tail, and Gina could get a tail. So that's one option, one outcome that can occur. Then you can have Trina getting tails and the other one getting heads. You could have tails, heads, tails. You could have heads, tails, tails. You could have heads, tails, heads. Now, how you can figure out how many total options you have is you can go back to permutations or fundamental counting principles actually, and there's 3 stages to picking a coin. There's 3 spots because there's 3 coins you have to flip. Well, each of them have 2 options because you can have a head or tail, head or tail, head or tail for each case, and if you multiply them, you should know that there are 8 total outcomes that can occur. So that's what we have to figure out is the total outcomes that can occur. Well, I could have heads, heads, tails, so there's 6. I could have them all be heads, 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 heads. And then we have to figure out the last outcome is what if I have 2 heads, so I have that outcome. Let's see, how about 2 tails? Let's go back. I could do tails, tails, and head. So 1, 2, 3, 4, 5, 6, 7, 8. So there's my 8 outcomes. So I was trying to find all the 8 outcomes, and those are them. The reason I need to list them is now I can figure out when does Trina win, when does Lena or Lena win, and when does Gina win. Okay, so I'm going to circle in another color. I'm going to circle when Trina wins. So if all 3 coins land as heads, so if they're all heads, like this case right here, this is where Trina wins. If all 3 coins land as tails, like in this case, this is where Lena wins. And finally, where otherwise it says Gina wins. So if you look, all these leftover outcomes right here, this is where Gina wins. Well, what I'm seeing is that this game is not fair. The reason being is that Lena has only a 1 out of 8 chance of winning. Trina has a 1 out of 8 chance of winning. So they're actually fair if that was it. If the game was just Lena and Trina, it would be fair. But because Gina has all the leftover pieces, that's actually 6 out of 8 options. Now we could simplify this, but this is the best way to compare them. As you can see that Gina has more chances of winning than anywhere else or any other person, so she has the advantage. So therefore, this game is not fair. Example number C, Anne and Dan each roll a standard die. If the sum of the 2 dice is greater than 7, Anne wins. If the sum is less than 7, Dan wins, and if the sum is 7, they tie. So when they're each rolling a dice and you have to do the sum or product in them, you're going to have to actually create a chart. So I'll show you what this chart looks like. One person will be Anne, so Anne will be at the top of the chart and Dan will be at the side. It really won't matter which one you do, but you're going to list the different numbers on a dice. Well, we know dice are labeled 1, 2, 3, 4, 5, 6. So that's Anne's dice. And Dan is going to roll this another dice, which also has those 6 outcomes. Now, because they're saying the word sum, we have to add up each set of numbers to figure out what the sum is. So, for example, 1 plus 1 adds up to 2. 1 plus 2 adds up to 3. 1 because of the row and 3 because of the column adds up to 4. 1 plus 4 adds up to 5, 1 plus 5 adds up to 6, and 1 plus 7 adds up to, or 1 plus 6 adds up to 7. Now we go to the next column. 2 plus 1, because you're always looking at the row that you're in, plus the column that you're in. Those 2 numbers should add up to, so we're looking at this number and this number now, add up to 3. And then this number and this number adds up to 4. And then we have 5, 6, 7, 8, because the last number is 2 plus 6 adds up to 8. Now we're in the third row. So 3 plus 1 adds up to 4, 3 plus 2 adds up to 5, and then we have 6, 7, 8, 9 if you continue. 4 plus 1 adds up to 5, 4 plus 2 adds up to 6, and then it continues that same pattern. 5 plus 1 adds up to 6, 5 plus 2, 7, 5 plus 3, 8, 5 plus 4, 9, 5 plus 5, 10, 5 plus 6, 11, and then our last row, 6 plus 1, 7, 6 plus 2, 8, 6 plus 3 is 9, and then we have 10, 11, and finally 6 plus 6 is 12. So that's what our sums look like. Now we can look at the inside portion right here and figure out what the sums look like to be able to answer the question. So now we're looking at this. They're saying that if the 2 dice, if their sum is greater than 7, Anne wins. So anything greater than 7, I'm in a circle. So all these numbers are bigger than 7. Oops, let me fix that. Bigger than 7 would be there. So this orange kind of circled area is when Anne wins. If the sum is less than 7, then Dan wins. Less than 7 would be these numbers. And they both win for the sum of 7. So in this row, we have this colored in with purple, and it also colored in with orange. Now, if we were to count all the purples, so 2, 3, 4, 5, 6, 3, 4, 5, 6. All the numbers that are circled in purple, I would get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. There's 21 out of 6 times 6 is 36 numbers. So that is the probability. Now with probability, you should always simplify your fractions to make sure that they're fully correct. So I'm going to go to my calculator and simplify it so I can divide this number by 3 and this number by 3 and get 7 over 12. So that's when Dan wins. Now let's do Anne. And if I counted all the orange, 1, 2, 3, 4, 5, 6, 7, 8, 9. So if I counted all the orange numbers, you would also get that there's 21 numbers out of 36 that are circled in orange, which again simplifies to 7 over 12. Since they both have the exact same answer, therefore the game is fair. Okay, so that's how you figure out if something is fair, is you actually look at their probabilities and make sure that they are the same. Example number 3, Everard says that he has a 120 chance of making the football team. Is it possible? Well, no. The reason being, in math, the max is 100%. Okay, if you have 100%, you have perfect. Or if you say 100, you're making it. You've made it. You're going to make it on the football team. There's no need to give extra. So when it comes to math, our max is 100. In probability, we should not have a percentage greater than 100. So when it comes to percentages, the max should be 100. When it comes to decimal form, the max should actually be 1, because decimal values, the max, if you added them up, would equal 1, because 1 whole means that that's all the different outcomes together. So in this case, don't go over 100% or don't go over 1 if you're in decimal form. Example number 4. So this is our idea of something called odds in favor, odds against. So odds in favor versus odds against. When they say odds in favor, what they're saying is that they want what you want, meaning what they're asking for, versus what you don't want. And how that relates to the last unit is our not want was kind of like the complement. These two numbers should always add to your total. So if you added them together, the want and the not want, they would add up to your universal. So it kind of relates to what we did before. Odds against is when you go not want to want. So what you don't want versus your want, your complement versus what you do want. So let's look at this question. An oil and vinegar salad dressing is made of 2 parts oil and 1 part vinegar. So the ratio is 2 to 1. So this is our want to not want. What fraction of the dressing is oil? This is another way of saying what is the probability. Probability should always be written as what you want over your total. So how we get that is our want is oil. Well, we know that there are 2 parts oil. So that's going to be our want, oil. Our total comes from always adding our want plus our not want. So in our case, we're going to add 2 plus 1. So we get that the probability is 2 from the oil. And our total, the want and the not want, meaning add these two numbers together, you should get 3. So that's our answer. Okay, so example number 5, we're going to skip. Reason being is that was using kind of a game that we do at the beginning of the class. So since we're not doing that, we're going to skip example number 5. Example number 6, whenever they say the word probability, what you're going to do is you're going to use the number and write want, which is the top number, your numerator, and the bottom number is your total. Okay, so what are the odds in favor of an expectant mother having twins? Odds in favor, we're going to write what you want versus what you don't want. Now, we already know what the want is. The want is 1, because that came from this number right here, which is our want, which we labeled. Now, to get our not want, we're going to take our total and subtract what we want. So it's going to be 1, 2. In our case, our total was 32, and we're subtracting our want, which is 1. That means there's one mother that is going to expect twins versus 31 mothers that are not going to have twins. So this is the answer for A. Now they want odds against an expectant mother having twins. Odds against is what we write it as not want to want. Our want is expectant mother having twins. So we already know that there's only one mother that is going to expect to have twins, and that's our want. So this statement right here is always your want. And then the not want is the complement, meaning how many mothers will not have twins. Well, we already found that, right? That was our not want right here. So they just switch spots whenever they say odds against in this case. So 31 mothers are not going to have twins. So this is our answer, 31 to 1. Example number 7. A computer randomly selects a university student's name from the university database to award a $100 gift card for the bookstore. The odds against, so we're going to highlight that, the selected student being male are 57 to 43. So 57 to 43 means that this is a male, because the first number, actually, let me go back. Whenever they say odds against, we always want to write not want first. And then this second number is our want. So that's what they mean when they say odds against. We need to label the number as not want to want. Our want comes right after the statement. So this is a student being male. So this is our want statement. So this number right here is the male students. What they want is determine the probability that the randomly selected university student will be male. Probability should always be written as what you want over total. Now, they want it to be male, so we already know that. That's going to be the same as our want statement right here, and there was 43 males out of. The total is when you add your not want to want. So the total is always adding your want and your not want numbers. So if I add 57 plus 43, I get 100. So this is already simplified, but they do want it to the nearest hundredth, so I'm going to divide the numbers and get 0.43 as my answer. Okay, so that's my final answer there. Example number 8. Suppose a weather forecaster states that the probability of rain today is 0.25. So probability is 0.25. Now I want to convert this to a fraction. So a real nice trick is if you go into your calculator, you put 0.25, then you press math, enter, enter. You're going to get that the fraction that represents 0.24 is 1 over 4. That's important because you need to label what your want is and what your total is when it comes to probability. So it needs to be in fraction form. The next question is they want the odds against. Odds against will be your not want to want. Now they want not raining today. So the want is not raining, which means that your not want is the opposite of that. So what is the opposite of not raining? Well, raining. And then our probability, if you guys look back, suppose a forecaster states that the probability of rain today is 0.25. This want is rain because of this saying, probability of rain today. So the want statement is rain is 1. Okay, so we know that there is one chance that it's going to rain versus how many chances is it not going to rain? We're going to take our total and subtract our rain. So 1 versus a total was 4 and our raining incident was 1. So we're going to have a 1 to 3 chance that it's going to, in this case, rain. So 1 to 3 should be the answer that you get from that. Example number 9. The grade 12 students want to include one more game in their charity carnival. They need to choose between game A and game B. Okay, so we have two games, game A and game B. So we know that the odds against is always your not want. So 11 is our not want to our want. So winning will be the 3 and not winning will be the 11. That's what that really states. The odds against winning game B, again, we have odds against, so this is our not want to want. Winning is always our want statement. So our want means 6 in this case. The goal is to raise as much money as possible for the animal shelter. So what we're going to do is we're going to figure out what's the probability of winning. Probability of winning for each. So we want to figure out what game to choose, and we'll talk about that later, but let's figure out the probability of winning, which would be winning, which is your want, over your total. Okay, so in game A, if you guys look, remember how we said that winning is going to be the second number because our want is the second number when it comes to odds against. So our want of winning is going to be 3 out of, we're going to have to go 11 plus 3 to get our total. So you always add the two numbers in order to get your total. So 3 over 11 plus 3 is 14. Okay, so this is game A winning. This is the probability, 3 over 14. Let's find out game B, the probability of winning. Game B, again, we know that the winning probability number is 6 because that's our want. Over our total is adding 17 plus 6 and we get 23. 6 over 23. Now, since they have different bottom numbers, we're going to have to divide them to really compare them. So in our calculators, you're going to divide 3 divided by 14 and you should get 0.21. to the nearest hundredth. 6 divided by 23 now is equal to 0.26. Now the question is, which game should we choose? Should we choose the one that wins more or the one that loses more? Well, because this is a charity carnival that they are hosting, they want people to lose, because if they lose, they're not going to have to give out prizes, which costs money. And 2, if they lose, the participant might want to play again, and then they'll spend more money. So we want the lower probability of winning. Therefore, game A is the one to pick. So we want the bigger probability of losing, which means the lower number in this case, in decimal form. Okay, so that's game A. Example number 10. In a survey, 35% of people on a diet did not gain weight. Okay, so we're going to have to set up like a little organization table here. So 35% of people on a diet, so these are people on a diet, did not gain weight. So I'm going to say weight, didn't gain weight. 48% of people who were not on a diet, so no diet, I'm going to put a cross through it, gained weight. So they actually did gain weight. Their weight went up. Now, if you add these numbers together, you're going to notice that these numbers do not add up to 100, which doesn't make sense. These are two actual separate pieces of data. So we're missing some of the numbers. So we're going to have to figure out our not want. So in the first case, we're going to have to go 100, take away 35, and that will equal 65 students, or 65% of the population. So we had to get this number by doing 100 minus 35, because all your percentages should always add up to 100 if you're talking about probability. So these are the people that were on a diet, but their weight did increase. Okay, and then we're going to have to do the same thing over here. We're going to have to take 100 minus 48, and we get 52% of people that were not on a diet, it's like its opposite, did not gain weight. Okay, so not on a diet, did not gain weight. With this information, now we can go back and answer the question. So if you ever see that the numbers are not adding up to 100, you're missing something here. So that's what you have to figure out the other number. So they want the odds against, so I'm going to write not want to want. And this statement right after is your want. Gaining weight if you are on a diet. So this is your want statement. So gaining weight, let's look at that. Gaining weight if you are on a diet would be, this is what you're looking at. You're looking at part A. So question A, you're looking at the first part of the data, because this is the gaining weight part and you have to be on a diet. So that would be the 35 and 65 number. So in our case, if you're gaining weight and you're on a diet, it would be this number right here. So we're going to put that in our want part. So we're going to put 65 right here. That means that the other number is your not want. So that would be the other number, which is 35. Okay. So once you have that number, you do need to simplify. So as you can see, these numbers can both be divided by 5. So you always want to simplify, just like probability, you want to simplify your odds in favor, odds against, by taking 35, dividing by 5, and you get 7 as the first number. 65 divided by 5 gives me 13, and this is my answer. So always simplify. For the next part, question B, it says odds against again, so we're going to write not want to want. And they're telling us that our want statement is gaining weight if you are not on a diet. Okay, so you are not on a diet, so that would be here. This is the question B that we're talking about, not on a diet. But you've gained weight, so that would be the 48, and that has to go into the want spot. Which means that 52, the other number that adds up to 100, should be the first number that you choose. And then you want to figure out what you can divide both numbers with. So I can actually divide both numbers by 4. So you're always simplifying these numbers. So in the first case, you divide by the biggest number you can for both, which would be 4, and you get 13, which is 52 divided by 4. And then 48 divided by 4 is 12. So that's your answer. So always simplify. Okay, so that's it for lesson 3.1, 3.2. So what you want to do is make sure you've copied in the notes, and then you try a few homework questions just to see that you understand it. Ask me for help if you need it, or if you need some kind of clarification or explanation, please.